so we're going to perform transformations on logarithmic functions now. This is your last one that you're going to try for. Okay? So your last type of function to learn in this unit. So label the graphs with either c greater than 1 or c between 0 and 1. So remember, the increasing function is the one where c is greater than 1. So that's the increasing. And the decreasing is when c is between 0 and 1. Okay? Asymptote, remember, is the y-axis. All right, so we're going to look through, describe the transformations that are made on these particular logarithmic functions, and then some of the properties. We're going to be asked to graph these as well. So sometimes you might find at the beginning that maybe you want to graph it first and then come up with the properties. But, so that would be with your calculator if you weren't sure. But we have learned transformations. So we should be able to get all of this information and then graph it based on that transformation. And then you can check with your calculator. So, first one. Base graph is this. So we've replaced now x with x over 2. Remember, that could be the same as 1/2 x. However you want to show that. The transformation, excuse me, then, I'm just going to use short form, short form, not that though, horizontal stretch by, well, if this is x over 2, you take the reciprocal. So horizontal stretch by 2. So think about that. If we look at either one of these, if I horizontally stretch this by 2, does my asymptote change? No, because it is the y-axis. So remember, when you're horizontally stretching, it's about the y-axis. So anything on the y-axis will change. If it's an asymptote, it's not going to change. So the equation of the asymptote is still x equals 0. And the domain is normally x greater than 0. So if you stretch it by 2, it's still going to be x greater than 0, because 0 times 2 is 0. Okay? Range, that has nothing to do with a horizontal transformation, so x is going to stay as element of the set of reals. Your normal, on your base graph, your x-intercept is 1. Now, if we horizontally stretch by 2, it's going to become 2. Okay? So, that's going to change. So that's a horizontal stretch by 2. Vertical stretch by 2 is the 2 outside. Well, if you've got a vertical asymptote, stretching that by 2 doesn't change that vertical asymptote. It still stays there, right? So that's going to stay. Vertical stretch doesn't do anything to the domain. And because we started with all real numbers, stretching that by 2 will still be all real numbers. Okay. So then, x-intercept. So our x-intercept is 1. It's on the x-axis. Does anything on the x-axis change with the vertical stretch? No. Remember, it stays the same. So that's going to stay as 1. Okay. Then the next is a reflection. And the x-axis. So you're changing the same sign of y. So reflecting, the x-axis doesn't change the asymptote either. Okay. If we're reflecting in the x-axis, so this point would stay, this would go up here, this would go down here, still to the right of the asymptote. So that's not going to change either. Particular values will change, but the range, because it's starting as all real numbers, will still be all real numbers when you reflect in the x-axis. And again, just like a vertical stretch, anything on the x-axis stays the same. So the x-intercept of 1 will still be 1. Okay? So now we're reflecting in the y-axis. So if we're reflecting in the y-axis here, then this point will go over here, this will go over here, but that asymptote is on the y-axis, so it won't change. So that will stay the same again. But what happens to the domain? That's smaller than 0. And everything's flipped over, right? So now it's x less than 0. And that doesn't affect the range. So that x-intercept of 1 on the original, we reflect in the y-axis, becomes an x-intercept of negative 1. And the last transformations. So this is in brackets here in the argument. So that's a horizontal translation. What is that? Left 4. Because we're adding 4 to x. Okay, so now think about your vertical asymptote. If I'm shifting everything in my graph 4 to the left, then that asymptote has to go 4 to the left as well. Okay, so that asymptote now, finally, that's something that will affect the asymptote. So horizontal translation will affect that asymptote. So our normal graph is x greater than 0 for domain. If I'm moving everything over, then it's going to be everything greater than negative 4. And basically, think about it. We know that our argument has to be greater than 0. We've never done a log with a negative in the argument. So x plus 4 has to be greater than 0. You solve that, you get x greater than negative 4. Okay, that's your domain. So you can always just take the argument and set it to be greater than 0 and solve for x, and that's your domain. Again, not going to change the range, but now our x-intercept was 1 to start, right? Now we're moving 4 to the left, so this is going to be at 3. Okay, or sorry, negative 3. 1 minus 4 is negative 3. How do you check it? Substitute it back in. Negative 3 plus 4 is 1. Remember, any log with an argument of 1 has a value of 0. The x-intercept has a y value of 0. Okay. Now, take a look at the difference between these. So this is x plus 4 in the brackets, guys. This is log of x base 3 plus 4. That's outside. So that is a vertical translation. So you need to be aware, anytime there's a plus or a minus, then if it's with the argument, there has to be brackets. If it's a multiplication, like say you had say you had something like this, then that would be considered to be the argument. So together, you may or may not have brackets, because really, if you're wanting to multiply the whole log by 2, you would show it out front. Or the whole log by x, you would show it out front. So this is understood to be together, but for adding and subtracting, if you want it inside, you have to put brackets. So this is a vertical translation. So remember, vertical translation doesn't affect anything on the y, or vertical translation of these points on the asymptote, we'll just move those points, so it'll still be on the y-axis. So it'll still be x equals 0. Okay, then vertical translation, that's not going to change the domain. Right? The domain was x greater than 0. If you move everything up or down, it's still x greater than 0. You move everything up and down, it changes each particular y value, but the original range was all real numbers, so that's not going to change. Okay, now think about the x-intercept. If I take this and I move this up 4, then I have to move every point up by 4. So maybe it's going to look something like that. It's not going to have that same x-intercept, right? So how are we going to get that? I can't tell. I don't have a calculator. I don't have it on my calculator. You can obviously do it there. You can use algebra, exactly. So based on this, for an x-intercept, we know that y has to be 0. So we substitute it in. We want to isolate x, so I'm going to bring you over 4. Okay, and then it's a question like we were doing yesterday. We want to find the value of x. So I do my swoop, and x is going to equal 3 to the negative 4, which is 1 over 81. Okay, so as I mentioned, it's asking you to graph all of these. We're going to just do a couple of them. We're not going to do all of them. So let's do these last. Actually, we'll do A, and then we'll do D for sure, and then let's do. Okay. So A is g of x. So I'm going to put it on this. Notice how we've given you the base graph. So you can just perform the transformations based on that. So horizontal stretch by 2. So there's an x-intercept. Stretching by 2 will give me a new x-intercept. Okay. Remember that asymptote doesn't change. So actually, I'm going to draw that in first. So that's not going to change. But that point there becomes 2. This point here is 3. So when I stretch that by 2, that will be 6. So just choose a couple points like that. This one is 1/3 approximately. So times by 2 is 2/3. It'll be a little bit like that. Just get at least a couple of points. Okay, so that's y equals 2x. Okay, then we're going to do m, so d, m of x equals log of negative x base 3. So that's on this one. You can go back in and do the other ones. We're going to do this, and we're doing this. So this is reflecting in the y-axis, so that asymptote doesn't change. So this 1 here becomes negative 1. This 1 for y, 3, 1 for the original becomes negative 3, 1 for the reflection. 1/3 negative 1 becomes negative 1/3 negative 1. So we've got a few points there. Maybe you want to do 9, 2 becomes negative 9, 2. Okay, should look like an exact reflection. Okay, and then we'll do, actually maybe we'll do E as well, we'll do Q next. So translating 4 to the left is going to, oh actually, so we're going to do this one. 4 to the left, so I'm going to transform. My asymptote is now going to move 4 to the left. Okay. This point here, the x-intercept, 1, 2, 3, 4, ends up at negative 3. 3 to the left, 4 is at negative 1. 9 to the left, 4 is at 5. And then I'll be 1/3 away from the asymptote. And then we'll also do okay, so our original, our asymptote is not going to change. Maybe I'll do it in. So then, their original, I'm moving everything up 4, so 1, 2, 3, 4. 1 plus 4 is 5. 2 plus 4 is 6. Okay, and then 1/3 away from that, so there. This one you really should make sure that it crosses the x-axis on the graph, even though you know it's approaching, just because we did have to find the x-intercept. 180 first is pretty small. It is. It's a step, right? Okay, if you have, oh, I don't have my calculator out. Check, so give me a sec here. Okay, so let's check the last one. Y equals, so if you have newer version of the calculator, then you can go math P log base, in this case base 3 of x. Make sure you cursor out of the brackets plus 4. And let's just use a standard screen. Notice that you can't see the blue because it's so close to that y-axis. Doesn't mean it doesn't exist. You trace along there. It's starting at the asymptote, and then it's jumping right there. But for example, if I want to, it doesn't even, you can't even see where the x-intercept is. But if I think it's 1 divided by 81, it's going to flash there. It's just you can't see the blue as it gets there. But that tells you that that's the x-intercept. Okay? So you could obviously zoom in if you needed to. If you have an older version of the calculator, then what do you do in this case? You use your change of base. So you go log of x, so the common log, close the bracket, divide by common log of 3. Okay? Oh, no, sorry. Plus 4. Plus 4. Just give me a second. Okay, so in here, I forgot to add 4. Plus 4. Okay, so there's the original. And then it should overlap, right? Okay, so Tristan, get that? This is what you're going to graph. That's what you're going to graph. Okay. All right. Okay, so did any transformations affect the range? We look back in our chart, but none of them did because it was all real numbers to start. Okay, the only transformation that affected the vertical asymptote that mu did was a horizontal, right? Anything vertical won't, any horizontal stretch won't, but a horizontal translation. Okay, what affected the domain? Well, a horizontal translation will as well, because it affected the asymptote. What else? Reflection, right? About the y-axis. About the y-axis, yeah. Okay, so reflection about the y-axis doesn't change the asymptote, but it does change the domain. Okay, so state the domain of each of these. I'm just going to go back to full view here. Okay. So, when you have a big logarithmic function that's been transformed, you might think, oh, I need to go through all the transformations in order to figure out what the domain is. Remember what I showed you as a fast way, right? The vertical stuff is not going to affect the domain. This is the argument of your logarithm. That has to be greater than 0 in order to be defined. So, this, do we really even care about the 2? We don't, because it's positive. Now, if that was negative 2, we do care about it. But it's positive, so I always include all of the argument in that, just in case it's negative, right? So then you don't mess it up. So then if I divide by 2, both sides, 0 divided by 2 is 0. And then I just solve for x. So that's my domain. So then you can put it in. Okay. Really, everything, although it's been stretched horizontally, that asymptote doesn't change, but then we're translating 5 left. So this one is not in transformation form. You could factor out the 3 and then see what the horizontal translation is. Or you can just go straight to that definition and solve for x. Okay, and then you can put it in your set builder notation if you want. So say with the next one, now notice the order this is in. 4 minus x. Normally we have the x first. If we just go by what I've been doing here, we know the argument has to be greater than 0. So get x by itself, but what happens when I divide by -1? There's inequality sign flips around. Okay. think of how that works. So don't just like try to understand why. If we started from here, and instead of subtracting 4 from both sides, I added x to both sides, the x would be at the little end of that inequality, the smaller end. So x would be smaller than 4, right? If you don't do that, then you're dividing by a negative, which changes the direction of that inequality. Either way. If I show this in proper transformation form, then I would need to, well, first of all, if I rearrange it, then I need to factor out a negative 1, and that would be x minus 4. So then, I know that my asymptote's at 4, and this has reflected in the y-axis, so it's less than 4. Just so you know, the answer key on Schoology, it's incorrect here. I think it says x is less than negative 4 or something like that. And it messed up the sign for now. Okay. All right, so to summarize, in general, if we've got log of x base c is transformed, then the equation of the vertical asymptote is the x equals, right, it's a vertical line, and it's equal to that h. Remember, for exponential, it was horizontal, and it was y equals the k value. So this is x equals h. Range is all real numbers for logarithmics. Okay, now if b is greater than 0, then we haven't reflected it in the y-axis. So the domain is going to be x greater than that h value. Okay. But if you reflect it, so if b is negative, it's going to be x less than h. But again, if you use this method, you don't really have to think about transformation, right? Solve it for you. Okay, since you can only take the log of a positive number, another way to determine the domain is to find all the values for x where this is greater than 0. And that's what we were doing up there. All right, that's the most efficient way. All right, so there's a similar log function, algebraically determine the x-intercept. So that's when y is 0. Okay, so you want to get the term or factor with x in it by itself. So dividing by 3, algebraically determined, it didn't say using transformation, so that's why I'm using the equation and substituting 0 in for y. Okay. And then here, that means, remember, if I do my loop, I get 4 minus x equals 2 to the 0. You can check it. Take 3, put it in. 4 minus 3 is 1. Log of 1 is always 0. 3 times 0 is 0. If you think about transformation, right? So So your normal X-intercept is 1. If I reflect it in the y-axis, it's -1. If I go right 4, -1 plus 4 is 3. So I could just state this using transformations or algebraically determining. You can check that with your calculator on your own time. Okay, describing transformations here. Notice that the bases are the same, right? Otherwise, the different graph, right? So we are transforming this graph into this. So it's stretched, there's 2 stretches. So you can start with vertical if you want, by a factor of 6, above the x-axis, and then horizontally stretched. So you can switch these around, right? There's 2 stretches, it doesn't matter which order. And so that's a 2 there, so it's going to be about 1/2 about the y-axis. Okay, and then there's a reflection about the x-axis. So by the end of this course, those questions about transformations should be your best work of your whole evaluation for all your assessments. Graph of y equals log of x base c is vertically stretched, horizontally stretched, reflected, translated. What is the equation in transformation form? So you can do it in steps if you want. You might want to do the stretches first at the same time. So vertically stretched. Then horizontally stretched by factor of 1/2 would be 2x. Okay. So I've done the stretches. Reflected in the y-axis. That's going to make that replace x with -x, which will end up being -2x. Can you simplify that? Okay. Then translated 1 left and 4 up. Brackets around where x goes. Left is +1, and 4 up is outside of that. Then take a look. Is it in the form that's asked? Is it y equals yes? There's a coefficient. Is this in factor? Right? Some of you on one of the tests earlier this year didn't look and compare your answer to what it had. It didn't have a v. And you guys gave me a v, or vice versa. I can't remember exactly. Make sure it's in that form that's been asked. Okay. Transformations again. So same base. There's only 1 stretch, so vertically stretched. By a factor of 9 about the x-axis. Remember, although your diploma exam this year is only worth 10%, okay, it goes on your transcript. So your mark from your course that you learned here goes in, your mark from your diploma goes in, and then the overall mark, right? So it's not going to affect your mark very much because it's only worth 10%. But universities, because they can see it, I think they're going to look at that diploma score and mark. Okay, whether they factor it in per se, that's going to be a deciding factor between 2 people. Certainly it would be for me if I was, because that is common to everyone in the province, right? Whereas maybe some teachers have been really lenient and some really hard. And so that diploma exam will maybe be the tiebreaker between someone with the same final exam or final course mark. You did well on that diploma. It also shows that you don't give up on things, right? And just say, oh yeah, doesn't matter. Just gonna go walk in there and not study, right? Does the university want that? Not really. So be aware of that. Because I know some universities don't say exactly how they determine who gets entrance. There's obviously some averages in certain programs, averages of their top, their 5 grade 12 courses. But universities like UBC have different components to their application. So they're 5, either English, social, math, science, one other kind of thing. Then that's part. Then part is maybe a paragraph or an essay that you have to write. I can't remember if UBC does that now or if they used to. In any case, there might be that. There might be. So UBC looks at what kind of courses you take. Is there depth? They call it depth and breadth. So having taken IB shows them that you are interested in learning more. It is going to deeper level in some of the concepts, and breadth in the sense that we're doing more, right? In IB we have to do Alberta, but we also have to do stats and probability and other concepts. So but they won't tell you how much your application is worth because of that, but it is a part of it. And they also say they're going to look at your overall grade 12 every single course package. So there's different parts, right? And every university is a little bit different. So do not say, oh, the diplomas are only worth 10%, I'm going to do nothing. Okay? Please, and thank you. If you don't do that, I will thank you afterwards. Okay? So do yourself a favor in the long run. Even though you're not applying right now for universities, maybe next year, a lot of you will. Maybe you take a year off, you're going to do it a year afterwards. You don't want to have to go, worry about it. The nice part is it is only worth 10%. So if you have a strong mark going in, if you don't do as well as expected, it's not going to ruin your mark. But you want, so maybe take some of the pressure so that you go in and just do the best that you can, right? Okay, so let's get some properties for this one. So the normal asymptote is at x equals 0. Now, stretching it vertically is not going to change that. Reflection in the x is not going to change that. It's going to be the translation one left. Okay. Range. I'll just leave it without set builder, just as all reals. Domain, then, it has not been reflected in the y, only in the x. So it's going to be x greater than negative 1. If you want to look at x plus 1 and make it greater than 0 and solve that, you can. Or you can start it in terms of transformations. Okay, y-intercept. Because this has been moved, right? So it's going to have a y-intercept in this case, where normally the base graph will not have a y-intercept. But now it's been translated left. So there's going to be a y-intercept. That's when x is 0. So put 0 in for x. Now we're finding, guys, log of 1 base 3. Remember, if your argument is 1, then this whole thing goes to 0. So this is going to be equal to 18. The argument is 1. The only way exponent on 3 that will give you an answer of 1 is 0. So the value of the log is 0. X-intercept, that's when y is 0. Okay, so I want to isolate the term with x in it. So this is negative. I'm going to bring it back to the right. This is going to be positive. Divide by 9. Okay, and then just like yesterday. Okay, so 3 squared equals x plus 1. So 9 equals x plus 1. So x equals 8. That's algebraically. You can obviously graph it, and I'll leave that for you to do on your own. What we might do at a diploma exam or one of ours is just so that you can't just graph it and find the x-intercept, maybe we don't give you the base. We call it c here. Right? So then when you get down, you have c squared, and then you would have to show this as c squared minus 1. Right? Now, obviously, you could choose a base and then work backwards, but that would mean that you actually can't just plug it into your calculator and find the x-intercept. You actually have to know this step. Okay? Okay, mapping notation. This time log base 2. Describe the transformations again. So I'm just going to use short form in this case because we've done it a few times already. I'm going to look there and there. So horizontal stretch. Remember, it's going to be a half because in mapping notation it is what it is. So stretch by half, vertical stretch by 3. Reflection, so we changed the sign of x, so that means it's reflected in the y-axis. And then, once that's all done, we're subtracting 1 from the x value, so that's left 1. And after this is all done, we're adding 5, so that's up 5. Okay, it's not transformation form, it's mapping notation. It's basically whatever is done there, it's multiplying, it's stretched, adding, it's up, to the right. Okay, so 8, 3 lies on the original. Determine the coordinates of its image point on the transform. So remember, you don't just substitute 8 in your new graph. You have to transform that whole point. Okay? So we follow the steps. So 8, 3. We're going to horizontally stretch by half, which will be 4, and vertically stretch by 3, which will be 9. So this is for stretches. Reflection in the y-axis changes the sign of x. And then left 1 and up 5. So left 1 here is negative 5. And up 5 is 14. write the equation of this. I'm just going to do it above. Or actually, I can push this down a bit. There we go. Okay, so vertical stretch by 3. Horizontal stretch by half means there will be a 2 there. Reflected in the y-axis makes that -2. Then we're going left 1, so that's going to be x plus 1 in brackets. And up 5 would be plus 5 outside. Okay, verify the equation using the image point from part B. So we're going to use -514. And we're going to verify. So our left side is y. Our right side is 3. Log base 2. -2. Put negative this and that. -5. So what's that? That's -4 times -2 is +8. Okay, then you evaluate your log. Log of 8 is 2. Well, 2 cubed is 8. So that has a value of 3. And 9 plus 5 is 14. Then the domain, you can use your transformations, or you can find the values of x that make -2 bracket x plus 1 greater than 0. Okay, so -2 bracket x plus 1 greater than 0. So you can divide by -2 here. You can expand out, up to you. You divide by -2 right now. Then remember, you have to change the direction of the inequality. And that's your domain. If we think about the transformations, the vertical stretch doesn't change the domain. Starts as x greater than 0. Horizontal stretch doesn't do it. Reflecting makes x greater than 0, now x less than 0. Then we're going to the left 1, so now x is less than -1. So you can use transformations. This just says state. I showed work, but you don't have to.